Hey guys, good evening. Welcome back to my algorithm challenge. I missed overall 2 days for my algorithm challenge. I think I'm on my day 45. I've had some issues, mostly due to my stay in the Netherlands. So I had to settle some of those, but now it's okay, or at least it's looking fine for now. So it's patched up. But we're gonna continue with revision of our algorithms. I'm just going to share my screen. I think we were doing methods on string. So um, we were doing these checking on arrays, intersections. Um, Now we're going to move on with the last method of string, revised last method of string, which is prefix sum. So what is a prefix sum? We did that. It's a technique that can be used on arrays. Idea is to create an array called prefix, as you can see here, um, where prefix I, so prefix I, this is a sum of all the elements up to the index I. So um, given index like p equals 1, 5, 6, 7, p prefix be like 1, 5, 11, 18. So it gets added up, the elements. So um, when a subarray starts at 0, index 0, it is considered a prefix of an array, and a prefix sum represents all sum of all prefixes. Now, the reason why we use prefix sum is because it allows us to find the sum of any subarray in O1 time. So if we want to find the sum of the subarray from I to j, so I, j, we also learned that we can represent this by using was um, prefix j minus prefix I plus nums I, right? So that is the sum of the subarray from I to j. Uh, this works because prefix I minus 1, or this could be also represented by um, prefix j minus prefix I minus 1. This only works because prefix I minus 1 is sum of all the elements before index I, and when you subtract this from sum of all the elements up to index j, you're left with the sum of elements starting from index I and ending with index j, right? So that's the logic behind it. Now, let's go through this template. So from the first line, you can see that prefix array 0. This is almost always done when you're using prefix. It initializes a new list prefix with the first element of the input array. This means that first element of the prefix sum is the first element of the original array. So nothing too crazy, just initializing. And we loop through the array. So we start from loop I minus I equals 1, and then goes through each element of array until the end. And then we update the prefix sum. So for each array I, it computes the function computes the new prefix sum by adding the current element array I to the last element of the prefix array, which is prefix minus 1. So as you can see, we just append to the prefix the last element and the current element, and we return the result. So nothing too crazy. It's pretty simple. The last thing we looked at from the string chapter was how to build effective string. So we're gonna go through this code. So we just initialize an empty array. This is used to collect the characters from the input list array. And then after that, the function iterates through all the elements. So character C in array and append it to the answer. And then just, yeah, convert list to string. Oftentimes this naturally came, right? Because you don't really need to know the data structure, although this template is good to know. It's just good to know. So it is what it is. So we can just use it whenever we want. It's a way to combine a list of strings into a single thing, disjoin, if you haven't known it yet. We're gonna go into linked list today. So we looked at the most common method of utilizing a linked list, which was fast and slow pointer. So the difference between array and a linked list was that array is implemented in a way that elements are stored contiguously in memory. So let's say you declare a 32-bit in memory to 32-bit integer to hold it by an array. And each element in the array is at address that is 32 bits away from its neighbor. So this allows us to access elements in an array with indexing. However, on the other hand, linked list is also similar to array, but it uses nodes. So each node will have a next pointer, which points to the nodes representing the next element in the sequence. So it's all connected with this pointer. Not to be mistaken with the fast and slow pointer that we're going to use. The pointer that we're going to use is the one that declares the location of the node, whereas these pointers in the nodes is just the imaginary pointers that connects each nodes. So yeah. So main advantage of linked list is that you can add and remove elements at any position in O1 time. So time complexity is almost non-existent. Although you need to have a reference to the node at the position in which you want to perform the addition and removal, and that is usually done by pointers that we're going to discuss in this template. Main disadvantage of linked list is that there's no random access. So if you have a large linked list and want to access 200,000 elements, then there usually isn't a better way to start at the head and then iterate 200,000 times. So while the array has O1 indexing, linked list could also require ON to access the element at a given position. So that's the main disadvantage that could come up in an interview. Now, how we use the slow and fast pointers. The logic is simple. You initialize one slow pointer and you initialize one fast pointer. And oftentimes fast pointer will move twice as fast as a slow pointer. And then we're gonna find out where it meets, and oftentimes that's the answer. So slow is initialized to point to the head of the linked list. This will move one step at a time. Fast is also initialized to the head, but this will move 2 times, 2 steps at a time. And answer is initialized to 0, right? And now we loop as long as fast is not none, and fast.next is not known. So this ensures that fast pointer can safely move 2 points two steps forward without running off the end of the list. And inside the loop, the function will provide some kind of logic that is not specified in this template because we're going to implement it when we are solving the question. But yeah, that is the main logic behind it. Yeah, just the difference in the speed where it progresses the slow and fast pointer is what will solve the question, and then it will return the answer. So yeah, guys, we did 3 simple data structures today. Tomorrow we're going to continue with linked list and also the hash map. Thank you guys all for listening, and good to see you guys again.